informazione arriva in tempo.
Va bene, ok.
Io devo salire un attimo solo.
Quindi possiamo cominciare. Aspetta, ma
no, devo solo un attimo che non ho capito cosa.
Adriano, il problema è questo.
Sì, mi hai detto, mi sono scordato di prenderlo, vogliamo provare un altro capo? Però io sopra ce l'ho.
Forse c'è bugia?
Bugia dovrebbe essere, no? Bugia.
Forse c'è, sì.
i dati sono quelli che inizio qui,
Cambio con
pit stop.
Ci pare su una casata di una persona.
Oh, Technicolor.
Iniziamo? Bene. Bene. Okay. Oggi plotting tools. Okay? Let's learn how to make very fancy plotting. So we are going to learn the basic plotting, how to make multiple figures, multiple axes, how to put text in figures, that include legends and titles, how to represent function, histograms, error bars, bidimensional data, 3D plots, geographical maps, and how to save. Okay, and some exercise to make here. Okay, so let's start. So, very quick plot. We import matplotlib and NumPy. We are going to work basically with these two. We create a list, an array of 10 numbers, and we plot. That's very simple. Remember to put here PL show and PL EO. So like this. Import matplotlib plot as PL show PL EO. Okay, so we want to show the plot once it's created, and we want to make interactive. Okay, now we make the plot with PL plot and the variable, because we give only one number here and not only an array. It's going to take us the x-axis is a consecutive number, 0, 1. So for first value is 0, and for the second one, and so on. Okay, so that's a very quick plot. But let's do another very. Is everything okay? Yeah.
Okay. Just a moment.
Same plot. Okay. So that's is just plot. Very quick, so it decides what type of color put, what usually plot lines, and so on. So this is very quick. To clean
This is plotting x versus x, or x,
yes,
versus index of x?
X versus index. Okay. So in the x-axis is the index, if you don't give anything. It's very quick plot. And you don't have to decide what color, whatever. Okay. So one thing very interesting is, for example, if you now plot x by 2, Python is going to change automatically the color, so you can distinguish. So try to plot x by 2.
No, okay, yes.
Okay. So it should show
Yes.
with a different color. So anytime you plot a new one, if you don't give the color is randomized, so it doesn't match the previous one. Okay. So understood?
Mm-hmm.
Okay. So to clean the figure.
Okay, so it's online. The color is random. It's not a sort of.
It's random. It's random.
Okay.
But all is changing always. Okay. Because we will see there are hundreds of possibility of colors here. Actually, whatever you want. Okay, so we can plot in the same line different curves also, function. For example, let's clear the PLCLF, clear the figure. So that doesn't close the figure, just clean the axis, okay? And we can start over. Now we define x squared and x to the cube, like this. So we have x to the square, and x to the cube, like this. This is power 2, power 3. And we plot in the same line the three curves. We plot x versus x, x with this color marker, that means color blue and point. Then we plot also x versus x squared with this color and this marker. D is for diamond. We will see the different markers here. And x versus x to the cube with green color and this marker, which is a triangle with the upside. Let's see. Okay. Is it working?
What is the meaning of this?
Ah, this is the output of the. That means that Python done what you want and show some information. We will see how to use that information to modify with this information you can modify the marker and the color and all the style without replotting again. Okay? So by default, Python add the new plot to the previous one, so it doesn't remove what you have there. If you want to that any plot remove the previous one, we will use hold phase. Okay?
It's an automatic refresh.
Automatically is add,
Okay, this is a refresh.
and if we don't want to add, instead we want to replot hold phase, but by default hold is true. Okay, so if we plot something like this, we will the next plot will be removed. All the plot before will be removed. Okay, so this is a very simple plot, but we want to make very fancy plots.
Are you sure about hold? Because
Yes?
it seems so.
No, but is the following plots.
Yeah.
Okay, and you make that?
This has no property hold. It's
Should. No, it's hold.
It's a piano plot.
Yeah, it's plot. Let me check. Hold front, plot 2. Plot, okay. Argument, scalex, maybe it had changed some, okay. Okay. Hold. Oh, maybe it has changed this, in the, I didn't remove it. You're right. No, it has been removed, that option.
Yeah, probably. It is.
Yeah. No, because it's not here. No. This is
It doesn't say even if it is deprecated something.
deprecated.
There's
No? Okay. I don't know. I will look what is the
Anyways,
new
that's
one.
the whole.
Yeah. Okay. So I'm going to change that also in the text. Okay, let's say a very fancy plot. We can change anything with it. So let's create a data set of 100 points to be plotted with some random error. So we use line space.
So arrange, the function arrange is a function or a method?
Arrange is an NumPy.
A NumPy function,
Function.
is a function. So arrange gives you
So is the
generates a vector, an array equally spaced by 1.
No, not necessarily. Not necessarily. What it gives you, you give the for arrange you can give also the step. So that could be a floor.
So
the difference from here is that you give the
number of okay.
Yeah.
So okay, that's the difference.
That's the difference. Okay. So let's create a a variable x between these two numbers using 100. If you want to use the step, then you can use NP arrange. Okay?
Because in a range I cannot specify the minimum and maximum value. What is
Yes,
the
you
difference?
can. The only difference between line space and range is that in a range you specify the bin,
Okay.
and in line space you specify the number of points. But always you have to specify the minimum and maximum for floats. Okay? If you use an integer with a range, just giving a number and will give you a list between 0 and that number minus 1. Okay? A range is very useful if we want to create index, because with just one number it creates the index that we need. Okay? And line space is more for floats. If we want a specific number of points. For example, for draw function is very interesting because we usually we want the minimum and maximum and a number of points just to draw the function. Okay? So this is more interesting for draw function.
Okay. What is written on the fifth row? SX, I don't see.
Yeah, that is I think is the
I don't see the letter.
okay, SX, but you can name whatever you want. Okay? So with this we are adding normal error, Gaussian error to X. Okay? Actually, we are creating the error for X that we will use later. Okay? So let's create first the. I can better line now.
Just a moment. What is the meaning of size there?
Size, because we want the same random number like the size of X. Size is how many points do we have? How many points we want to create random. Okay. Because if we put just one, it's going to create just one number multiplied by X. So at the end, this all will have the same number of points like X, because X is here. So if you multiply by 1 point, you will have X multiplied all by the same point. Okay? The same number. If we put here just one. If we put the same length, like here X, each X will be multiplied by a different number.
It generates a set of random numbers equal to the initial
Equal to the length equal to the X. So each one will be different. Is more randomized. Actually, we could multiply this for anything different to 1 or the same length of X. Okay, because remember in NumPy the multiplication of two arrays is made element by element. Or you have one element and multiply everything, or you have the same number element to multiply one by one. So now, okay, everybody have these values. So now let's create the axis. So to create a figure, we use PL figure, and we can set up the side. These usually are inches. So we say figure side, this is X and Y. That is the side. So
is the size of the screen
of
or
the
size
figure.
Including the labels, the legends. So suppose I put a legend outside the figure. So this size includes the size of the legend.
Yes, this is all the window.
Okay.
This is the window, okay? We will see how to put outside the axis, the legend. Okay, let's create that, and we will see a white screen figure, no square, because this is like this. This is larger in X than in Y. Okay, and now we have this pointer that is an object. We have created an object that points to that figure that we have called figure. And we will use figure to add access and to save that figure to do whatever. Okay? So this because we have placed PL show and PL on, this will be shown immediately. And now we add figures with this. So if you now...
We didn't do any PL show.
You didn't? You should. Oh, you should.
There's no PL show here.
No, there is not, but I wrote here. Just to say, to add.
Okay.
I say it's not there, but you should.
Okay, so, okay.
Yeah, okay. So I'm going to modify, actually.
Okay.
Okay, now it's there. Okay.
Okay.
So we create the figure, and now with figure point tabulation, you will see that we have created an object with a lot of properties. One of them is that we can add an access to that. Okay, so we can add an access, and the access is added like this at subject access, and what we put here is the position and location, location and site of the access in normalized numbers. So between 0 and 1. Okay? So if the figure is the point is the side of the figure is normalized to 0, 1, the bottom left corner is 0, 0, and the top right is 1, 1. Okay? The coordinates of the figure. So we are telling here, okay, so put the axis. The beginning of the left corner in 0.15, 0.15, x and y, and with a side of this width, 0.8, that is almost the side of the figure, which is 1, normalized, and this height, okay? Notice that this will be, at the end, the side of the axis will be this plus this, okay? Not the side, sorry, the end of the corner will be located, the upper corner will be located at 0.95, 0.95, which is the sum of this. Okay? So be aware that this plus this could be not larger than 1, because the figure is normalized, is 1 of in length and width. Okay? So we have the axis with this, and the axis will be shown with coordinates between 0 and 1. You can change and try to make this difference. Okay? Or we have the axis added. Okay, so now let's set this, the text length, the text size, and the x. Okay, this should be say y. Okay, so the x and y text size, and this is the same like this. Okay, these do the same like these two. So we use tick params to modify this thing. This is now we have created an object which is axis, and the axis has some property that is change the length of the ticks, of the length. Sorry, the size of the text of the ticks. As you can see now, the text is very small, or is small. If we want to increase the label size, we will use this text param. Now, which axis affect could be separate. We can make separate label size for x and y. We can use different one, or we can use the same size. We can use in this, or also if we use for the axis keyword, we say both. This will be affect to x and y. Okay. So this includes these two. Okay. Okay. So it will increase. You will see immediately the size of the label. Okay. Okay, now we don't have minor ticks. We want to add minor ticks. It's very simple, just minor ticks on. And will appear minor ticks. Okay?
Can you specify the properties of the minor ticks?
Yes. Everything. You can specify everything. We will see. Okay. Okay, so now we have the axis with the largest label for the ticks. We have minor ticks on, and now we want to specify where to place the ticks. In the bottom, in the top, left or right, okay? So we in the same way we use ticks parameters, and this is the axis to be affected, x, where to put top true, bottom fails. Okay, we use for top and bottom, we can use true or fails, or in both. Okay, here we are placing the ticks in the top and in the bottom. Okay, and this means that we are also saying that not only ticks, the larger ticks, also the minor ticks. This is because which is both. Both mean minor and major ticks.
So doing is putting the tick outside the box. If I want to let the tick inside,
Then next one. Okay, now if you say here major or minor, you will affect only to major or minor ticks. So you can have, for example, you want major ticks in the bottom and minor ticks in the top. You can make anything you want. Okay? Is it working? Also for Y, the vertical axis. We say left true and right true because we want that in both. Okay? And we want which both that minor and major ticks will show on the left and on the right.
perché left e right.
Okay, so now note that we can use also here in the first parameter we can say both. Okay, if we want to make something which is the same for both axes, we can use both. So now, for example, that made no sense for the location, okay, because x is going to bottom and top and y left to the right. But for example, if we want to modify the length of the ticks, major or minor, maybe we want to do for both at the same time. So this is because we use both here to set up for the major ticks the length and the width. Okay, so let's do it. Change the major ticks length and width for both, and the minor ticks we can use a smaller. This is because our manual smaller ticks and different width. Okay. How is that? How is the figure?
Sebastian, something I've also seen in the programming with Python. You don't need to use ix dot. You can
No, you don't know. Ix, this is because, I mean, if you have only one figure, PL, whatever, get current axis and whatever, do the same, okay? But just to be sure that if you have a couple of axes, for example,
meaning
or
two figures.
or just one figure with two axes, for example, you want, maybe you want one axis to plot one type of function, and overplotting, that we will see that, or in the same figure, two axes, okay? But you want one in one way and another in another way. To say to Python which axis work with, you have to use this way.
Okay.
If you know, with PL, for example, directly, it works in the active axis.
Okay.
That is usually is the last one you have.
Okay,
working.
this is more flexible.
More flexible.
Okay.
More flexible. And more, this is go directly, you are saying do in this axis. We will learn how to do when it's the same, but this object, the name will be different. Okay?
The logic.
Okay? So, everybody have this fancy axis figure now? Okay. So, to change the direction of the parameters, we say, okay, we have two axes to the e-axis, our x-axis, to change the direction of the parameter. So, one of the property is what ax are both axes, y and x, the vertical and horizontal axis. So with get axis, we access directly to that axis, and now set tick params of that axis. We set up the direction in or out, which apply major or minor. In this case, both. Okay, and this will change the direction of the minor and major ticks to inside the figure.
And this way is also putting the big tick, the large tick in the corner of the plot. If I want to avoid this,
In the corner of the plot, how? Okay.
you have the tick disk, cioè you have the tick, the marker,
Yeah.
that are larger than the boundary of the plot. So they are very.
No, this is because it's outside.
No, I'm
No,
inside.
also inside.
I don't
I
understand.
have to increase the border, the line of.
Oh, that is because you have now is because it's placed automatically, okay? But now we would like to change the limits, or also where to put the ticks exactly.
No, but if I want, for instance, to increase the size of the line that is that surround the plot.
The axis, you mean the axis?
Exactly.
Oh, this is with another parameter we will see.
Because it's enough that I make.
Yes, you
half
can.
as the-
Yes. It's you can make the line width larger for the axis. Okay. Okay. But I think that actually that is how you see, but probably it's not plotted. When you save, it's saved with the same side, I think. But because I think we have created with the same side the figure. But let's see. Data. Okay. So now we can plot the data. Okay? Now. Okay. To decrease this. Okay. So we use we want to plot in the AX axis, so we use AX dot plot to say the plot is going to be in this axis. Now we have only one, so it should work also PL plot directly, but because we are using the AX, let's do it the same way.
Is defining
The axis.
that means the environment in which I am making this plot. So if I want to do at the same time a plot in another window,
Sure.
I have to call this in a different way.
Yes. Yes. Just to be sure that you are modifying the axis that you want. Okay? If you don't say nothing and you don't use the object associated to that axis, then it's going to modify the active one in that moment. So we plot X and Y, and now we have some keyword to modify the plot. For example, marker, you can set up this. We will see how many type of marker we can do. Have marker. MS is a construction marker size. You can write marker size or just MS. It's an integer, okay? So no strings. Marker face color. You can put for example, for a circle, you can draw a circle or a disc. You just say marker face color, a specific color. If not, it's empty. The circle is empty. Okay. This is marker face color and marker edge color. So you can have different color for the edge and for inside. Okay. LS is for line style. That could be different one. We will see. In this case, we are not using that. And label. This is very interesting. You cannot put label here. Doesn't matter. But label means that if later we want to plot the legend, the label for that plot will be this. What you put here. Okay. So let's put label data. So we plot the figure, and now we are going to plot a fit. We learned how to make a fit yesterday, the day before. Okay, so now remember polyfit x, y, and degree. Okay, this is a second degree polynomial. So we fit our data. This is the result. And now we create a set of X just to plot that fit. And we will use polyvar with the output of polyfit and the X that we want to use. We put color, we change the color. The line style now is a continuous. This is LW is line width. The width of the layer, or the width of the line, and the label. Okay. So let's see how is this working. change the width of the axis. Okay, do we have the plot right now with all the modification? Okay, so now let's add change the limits with this ax set x limit and set y limit, set the label for the x and y with this. Also we can specify the font size and add some color. Some text with some color. So for adding text we use text, the position in true coordinates, the text, and we can change if we want the color and the font size. Okay, what is mandatory is this. The rest it can be up to you. Okay. At the end, we add a legend like this because we have used a label. Is going to take the label of the plot and put directly. If we don't have label, it's going to put something like data 1, data 2, whatever. Okay.
But if we not specify color, font size, there is something.
Yeah. Yes.
Before.
Usually it's black. If you don't specify, and the font size, I think it's 8 or something like that. This is not mandatory, okay? This is mandatory.
Sebastian, I have a problem with this command. It doesn't
Okay, let's check. Which one?
This one. Text, font size, what to have. Problem. Valid syntax.
Font size. No, so but if you don't put font size, it's okay, right?
No, I don't.
Oh, it's the point. I have seen. It's a point there. Let me check something with this. Okay. So now with X with legend, the legend is automatically placed in the best place that Python determined. We can change that. We will see how to change that in the text section. Okay. But by now, doing that, it look for the best position to not cover the plots and show that with the label that we have used in the plot. So easy peasy. Okay? So now for the question of Santi, how to change not only the width but the color. Maybe we want a color for the bottom axis and color with the bottom. This is done with spines. So AX spines and can be used with 4 keywords: top, bottom, left, and right.
Can you say all?
No, all no, but there should be. I can have a look, but all is not a keyword. So set line width, change the width. Set color, change the color, so you can have different color for the top, the bottom, left, and right, or whatever you want. Let me check here. What are the keywords? No, it's right, top, I don't see. No, left, right, top, no. No, only left, right, bottom, and top. Okay? So you have to do in a list, in iteratively, or directly level. Okay, so clear now? Okay, let's what if we want to change something in the plot without replotting again? We can access to the object that are associated to each plot. For example, here for the first plot, we have called P1 to the data, okay? So P1 is an object pointed to that plot. So we can work with P1 to change anything of this. And P2 here is accessing the other to the feed. So now let's see if we can change.
Why do you need 0?
Yes, because the output is 2. 2 is a list of 2 elements. The output, the object is a list of 2. One is the first one pointing to the plot, and the second one is information associated. Plot has the output. When we use an object pointing to plot, has the output of that is a list of 2 elements, which is only the first one pointing that. For example, for error bar only has 1 element of output, so it is not need to do this. You can put P1 1 to see what is the information. So, but what is pointing to the plot is the first element of the object in this case. Okay, so P1 and P2 is a 2-element object.
P1, it says it's something. P1.
P1 is empty.
P1 1 is something. P1
0.
Sorry. P1 0 there is something. It
Yeah.
says it's a math plot link lines line 2
Okay.
blah, blah. And then when I
P1
P1 1 it says there's nothing. It's empty.
Can you press P1 enter?
P1 empty.
Okay, so it's a list. Yeah. Okay,
So
this is
there's
because
no P. So if we have
no, no, the output is 2. Let me check. The output should be 2. P equal P plot 1. Yeah. C is P0 is a list. Okay, maybe this has changed, but okay. For example, okay, let's. This should work. Okay, that's okay. Yeah.
Okay,
So now P is not a list. That is the thing. So now here we are expecting. We are saying okay. Only take the first one and leave empty the second one. Okay, output, because this has the output is a list, not an object. Okay. So if we want to access to the first element of the list is P0. This is only for plot. For other plotting function like error bar is not needed to do that because it's directly object. I don't know why. Plot the output is a list. For example, error bar key. Well, key. See, with error bar is not a list. It's directly the object. But with P, but with plot, P is a list. See, the difference between this is an object and this is a list. I don't know why this is made with plot. That is something internally of Python. I don't know why. In any case, for plot, because it's a list, we need the first element of the list. I think that is the unique one. You're right. So it's the unique one.
So if we need 0, but it's unique.
It's unique, but we need 0 because if not, it's a list, not an object.
Yeah.
Okay. The first element, which is the
only
only one.
element.
Okay. Okay. So with set marker, we change the marker. With set marker face color, we change the face of the marker face color, or line style, we change the line style of the second one. So try to change these things. Okay? You check it? Okay. So how many colors can we use? And actually, probably 16 million, because it's the internal limit of Python. You can also use HTLM colors with the hashtag and the color HTLM, or directly the name associated. Here I'm showing you some of them. So try to modify one of these. These are not all, okay? So let's say that you want to change to indigo. So you can use set marker face color to indigo, or use this HTLM color, okay? Try to change that.
All these commands are needed because we...
No, this is what we need.
Okay, the command before set marker face color, etc. These change what we want without reload the entire subject, the entire script. Okay.
That's right.
Otherwise, if we repeat the command...
Sure. You change the color, it will be there.
but it doesn't delete the before.
No, overplot.
Overflow.
Overplot. How to delay? That's a good question. We will see. Let's now delay something. With this, the object that remove, delete that one. Okay, you can try. Remove is a function. Okay, so parenthesis.
Okay.
Like this. Zero remove, P1 remove, and iterate the plot we want. So if we are using different plots in one axis, it's a good idea to have, if we are going to modify something, to have a pointer, an object associated.
Sebastian, a question on the generic thing. Why do we need parentheses in some cases for functions that do not need an argument?
Yeah, that's
Why? I mean, is it,
because
I mean,
because
effectively-
internally there is argument. It's self. Remember the class?
okay, so I can do also remove self. That would be the same.
No,
Okay.
no. This is you can, for example, if you define a function by yourself, you can define without no argument also, and we do whatever.
And in that case, I don't need parentheses.
In this case, you need parentheses.
I don't, or I do need.
You
Always.
need.
Okay. In all
Yeah.
cases.
Se devi riportare,
Okay.
devi prima.
Oh no, sorry, because
Yeah,
I've been
yeah,
removed. But for example, let's plot again.
Ovviamente adesso immagino.
It say it gives you information. It doesn't crack, but gives you the information about the function. Okay. So it says that this is method blah 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 blah. So to run the run the
You need to run.
yeah. So that's its internal. Internal is use self like in the class. Okay. And you can create a function with empty arguments. Okay, so let's do more things. So here are the color that you can use directly with keywords. With this symbol, you can use this symbol for this color, or you can use the long name with in the other example for different color. You can use all these symbols. Also, you can create your own symbols to make plots. And this is the description. Okay, you see we have a lot. And these are the parameters that control the type of plots. For example, for color, you see, for make marker edge color MSC, for edge width this one. We can also change the width of the marker. Okay, so running the face color, the marker size, line scale, line width, and we can use all this type of marker. Okay, so there are a bunch of them. Okay, multiple figures, it's very easy. Just, if we need several figures, just count twice, 3, whatever number. So with figure 1 or figure 2, we open figure 1, figure 2, we can make an object pointing to that, so we can add access to figure 1 using that pointer, or to figure 2. So you can try to open 2 figures, for example.
They are opened in the same window.
No, figure out separate one.
And if I want to put...
Those are access to several axes in the same figure, it's enough. Okay, so try to open 2 windows and add 1 access to each one.
avete aperto senza chiudere.
The previous window, I have to close the previous windows.
Come on.
I have to close the previous window.
No, it's not necessary. You can add the more window without closing the previous one.
E io ho avuto questa cosa bellissima.
I made this. Why it is not opening anything?
What? No, you
Yeah,
have.
but this. No, it was already here.
Sorry?
It was, I think, already here. No?
No, I don't think so.
And the other one is. This is.
Oh, because that's the window 1 and it's open.
So I have
put
to erase
3.
this.
Open another one. Just put 3. Yeah.
Mi si è allargata tutta, cioè.
Ok.
E come faccio a tornare indietro adesso?
Ok.
Così? Oh, ok. E quindi?
Close. I don't know what's close. Yes. You can make PL dot close all in string. It's a string.
And if I want to
All
close,
in string.
if I want just to close this one, for instance.
PL close and the number. PL close the number. F the number, not the pointer. F1, F1, F2, F3. Okay, do we have multiple figures? Everybody? If we want to close everything that is opened, there is a command which is PL close all. But all is a string. PL close all, close everything. All the windows that we have. Okay, so now let's see how to add the multiple access. To make, okay, just to make active one figure, just we use the number, okay, or we just can use the object associated, okay, like this. So to make active, so the next plot, if we don't specify the access, just with the library matplotlib, to be sure that the plot goes to the view that we want. Just we have to make it active if we don't use access, okay?
But they are active the moment when I open them.
If you have, yes, the last active is always the last one, or if you, the one you have clicked the last. For example, you open 1, active is 1. You open 2, the active is 2. But now if you click in 1, the active is 1.
Okay. Sure.
The active is determined by the system.
So in principle it's not necessary to write PL figure the one that I wanted to activate. It's enough that I click on the screen.
It's enough if you activate.
It's just
click on
if I
the
want
stick.
to make some macro.
Yeah, for example. Or for example, maybe you are moving both figures around the screen and you want to be sure what is the active, just click again, or just put that command. Write that command. No? Oh. Okay? So now, multiple axes. Okay, there is two ways to create multiple axes. One is automatically with subplot. Okay, so we use subplot with three numbers. The first one and the second one is the row number and the column number where to place the axes. And the last one is the axis index. So for example, this will plot in column 1 and row 3 the first axis. Okay? This no, sorry. This is the first two is saying in how many places divide the figure. Here we are saying divide the figure in 1 row and 3 columns. So we are going to put 3 axes side by side, okay? And this is say, okay, and plot in the first one, plot in the second one, and plot in the third place, okay? So the first two numbers is how to divide our figure in number of columns, in number of rows, sorry, and number of columns. So we create an associated object to each subplot, and then we can make plots just or just directly with this plot, or making active the plot with this command, set current axis, SCA, we set the current axis, and immediately we can plot without specifying the object also, okay? We can do it this way or directly with ax1.plot. Okay, is it working to plot? One is missing.
No, I didn't.
Remove.
Yeah, no, but what I have not understood is because I operated with X1, it should be this one. Why it is
No, because now it has been erased. Now X1 is 1, is a different one. Because you have created H1 again. So this is H1 now is this point.
Okay.
So as you can see, this is a fast way to make multiple axes to plot. And using the object of the axis to plot, or directly using active set current axis with that command.
It could be the same if we did instead of PL set current axis.
Directly
we
AX,
did like AX3
Yeah.
dot plot.
it's work.
And then
It's
it's
working.
the same thing.
Yeah, it's the same thing.
Then what is the convenience? So I can go back and forth. If I know if I do something, then I go PL dot SCA.
For
and
example,
go back to another plot.
I prefer directly access to the axis. Also, I prefer another way to make that is not this way, to make a multiple axis that gives you more control on how to show the axis with just with axis and setting what is the side. The good thing of this is that you don't have to decide the side. Okay, just how many you want.
But you can set the side anyway.
After that, okay? After that you can set up the side, after that accessing to the object. I mean, for example, with this you don't control what is the starting point of the axis, the left bottom corner. With the other, directly saying, okay, with this position you can access that one. So it's a fast way to make plots directly, okay? By dividing that with this. Well, how many rows, how many columns, and which one you want to plot. But there is also another way, that is the usual way, just adding the axis with the position, as we have seen before, okay? Now we have, here we create a figure, and we have two axes with two different positions, so the one axis in common overlap, okay? So in this case, we create the bottom axis, which start here, in this position with this width and with height, this width, and another that should be on the top, okay? Because this is the starting X position, the starting Y position, which is higher than this one, okay? And with the same width and side, and width and length, okay? So let's do it this way. So we can, for example, we can overlap. If they have an axis in common, we can overlap.
How I can erase everything? No, of the previous.
PL, CLF.
All.
You want to close everything? It's
Close all the windows.
PL close all. All is with a string. PL close like this. PL close all. This is very good if you, for example, if you are making a lot of plots in a script, and that are not shown because are 100. This is good to close everything, even those that are not showing, that are hidden. Okay, so have you write these two? Did you see the x-axes are not overlapping? So we want to overlap that. So we can change the position, okay, of one of them. For example, the bottom one, we want to change the position with this. So it takes the x2 axis and put in a new position just to overlap with the top one. The x-axis with the top one, okay? And now we can add two plots to this axis, to each one. Different one. Okay, perfect. Now change the bottom one.
When I gave the second,
The bottom
second
one?
position.
Yeah, but it's not created. It's not created.
Yes, I
Try to that.
before.
X2, okay.
Was this one?
It is not
Okay. Okay.
okay.
Oh, now PL, CLF. CLF with a function. Okay, and now X1. Oh, sorry. Could you delete? Write X1. No, A1 or AX1? AX1.
Yes.
No.
Ah, sorry. Yes.
AX1, and now the. Okay, now here. AX2. Write AX2. No, no. Okay.
Ah, okay.
No,
You
no,
need
no,
to
no,
change
no.
all
Yeah,
the
yes, yes,
okay.
because it's not.
Yes. But
Sebastian.
I've already written.
Sì.
I find.
If I rewrite the axis of 2, it is not, is very impossible.
No, because you have added, you have not changed it. You have another. Is the command is set position.
Set position.
Sì. Okay.
You have you have now 3.
Okay, okay. To erase this is
PLF, CLF. PL, CLF, so you don't lose the window. The window is the name. Pointing is the name. You can write the first letter. It will search only in the command of the letter that you write. You write AX1 and search. It show all the commands starting with that. Okay, perfect. That is directly yes, because you haven't changed. You have used it directly that one. Okay, so now we can plot anything. Let's say that we want to plot those functions and what's this? Okay. And set up some labels. We set up some labels and we can change the color of the labels with this EX label set color for both. Let's put in different color the labels. Or we can change the size of the labels with text parameters, remember, axis, X, and label size.
some problem with the peer.
SK. No, that's PL is something because. Okay, that's PL. So maybe let me check the here, right? Okay, because I think this is a L and not a 1.
Okay.
Probably.
Yeah.
Okay. So the library is now override
Okay.
with PL. Okay. So we can play a little bit with the color of the label, with set color, or all these parameters. We have seen how to change. It's something that we have learned. How to set the limits with this, with set limits. Also, that's very interesting, we can set visible and not visible the axis without erasing. Okay? Just set visible, false or true. Okay? Or we can, in the common x-axis of both axes, the top one, you can see that there is the ticks is placed there. So we don't want to show because it shares the same ticks than in the bottom. We can set tick label to empty for the upper axis with the set x tick labels empty. Okay? What if we want to use latex text? It's very simple with Python. For example, let's place one legend. Now, because we have two axes, we can have different legends, okay? So, for place one legend for the first axis, we use the object, and AX1, we have called that axis legend. What this, remember, we place labels, it takes the labels directly here in the plot. If we use the keyword label in the plot, the label shown, if we don't say anything, is that. Or we can set up pairs of the object and the text to place the label that we want with a different text. For example, here we place, using this object, okay, we associate this text, okay, object, and we set up all the objects here, and then in the same order the label in a list, okay. If we want to use latex command, the string should start with R in command, the latex command, whatever you want. Okay? So here we place rho symbol and here alpha symbol. Let's say that use this object with this characteristic of line, marker or whatever, and this text associated to this one. And for this, the same. For example, if in an axis we have 3 plots, P1, P2, and P3, what we should here, what we will write here should be P1, P2, P3, and in a list, the text associated to P1, P2, and P3 that we want to show. Okay? I'm going to make an example of that. Yeah. Okay. So this is the number of points that to be used. Usually, because if we are using, for example, circle and lines, usually show both. If we want to show only one of instead of 2, only one, we say number of points. Okay, equal to 1. You can do it without this to see what is the difference. And locate the location. If you don't write anything, it try to find the best location. But with this, we will see later how to work more deeply with the levels. With this, we say, okay, upper corner, left, bottoms, with this location. We will see all of them, okay? But at the moment, this is how to work with legend. If we want to set up a specific text, if we don't have any label keyword in our plot, that's the way. And how to use LaTeX. We will see.
Cioè R is mandato in order to call the LaTeX.
Yeah. Before the string, okay? Comma, whatever, comma. And you can use all the LaTeX language. Should we stop?
Yeah.
Okay. For starting with text in figures.
Yeah.
Okay?